Okay, so here we've got question 4c part 2, and you're asked to calculate delta H formation. So similar to question 3 that we looked at earlier. So it's formation from its elements in standard state. So our elements here, we've got nitrogen, hydrogen and oxygen. So nitrogen is N2 and is a gas. Hydrogen is H2, also a gas, and we have oxygen, O2, also a gas. And ideally we want to balance these, so we've got 8 there, we need to put a 4, double that, and that's fine. So let's do all our arrows going up to see what we're having formed. So we're forming water, got 4 moles of it, so it's going to be 4 times minus 133, which we get from the table. Oh no, wrong number, minus 242. That's why we've got to be really careful and double check our numbers. That is minus 968. We've got the formation nitrogen that's already in its elemental form, so that's going to be 0. So that gives us a total for this side, if we call it delta H2, just call that, I always call that side 2, but it doesn't matter what you label it, minus 968, and that's kilojoules per mole. On this side, we've got hydrogen peroxide forming, we've got 2 moles of that. That's going to be 2 times minus 133. And then we've got the formation here of N2H4, 1 mole of that, so that's going to be plus 75. And that gives us a total of delta H1 equaling 75. And we call this delta H3 for the sake of convention. Now, looking at that pattern, I've got a root here. So this root must equal that root there. So we can say that delta H1 plus delta H3 equals delta H2. So you can rearrange to make delta H3 the subject at this stage. So it would just be delta H3 equals delta H2 minus delta H1. But if you know you're someone who gets a little bit muddled with your negative and positive signs when doing the Hess cycles, it might be worth just plugging numbers in this state to minimise errors. Now I have made one error, which you've probably already spotted, that delta H1 is not the plus 75, it's plus 75 with the addition of the 266, so that gives a total, delta H1 is minus 191, apologies, did it on purpose clearly. Right, so let's plug in some numbers. We've got minus 191 plus delta H3 equals, our total here, minus 968. So I want to get delta H3 by itself, so I'm going to need to add 191 to each side. That gives me delta H3 equals minus 968 plus 191. That gives me a total of minus 777 kilojoules per mole. And that's the final answer. Now if you don't like drawing Hess cycles, you can use the equation we used previously, where we can talk about delta H equals the sum of the formation products minus the sum of the H for reactants. And if we input all these numbers, we get 4 times minus 242 plus 0 minus 1 times 75 plus 2 times minus 133, which gives us the same number as working with 1 minus 968, take away minus 191, which is the same as minus 968 plus 181, which equals minus 777 kilojoules per mole. They were happy for this question for either method to be used.